The steam engine, a marvel of human ingenuity and a symbol of the Industrial Revolution. This invention, powered by nothing more than heat and water, changed the world. It harnessed the basic elements of nature to create a force that could drive machinery, transport goods, and even reshape entire economies. It was the driving force behind the Industrial Revolution, a period of unprecedented technological advancement that reshaped human society. Factories sprang up, cities expanded, and the way people lived and worked was transformed forever. The steam engine's impact on history is undeniable. It not only powered machines but also powered the dreams and ambitions of countless individuals who saw the potential for a new world. It powered factories, mines, ships, and locomotives, ushering in an era of mass production and globalized trade. Factories could now operate on a scale never before imagined, producing goods at a rate that was previously impossible. Before the steam engine, most work was done by hand or by animals. This limited the amount of work that could be done and the speed at which it could be completed. Water wheels and windmills provided some power, but they were limited by location and weather. They could only be built in specific places and were dependent on the natural elements, which were often unpredictable. The steam engine, however, could be built anywhere and operate continuously. It was not bound by the constraints of nature, allowing for greater flexibility and efficiency in production. This breakthrough unleashed a wave of innovation and productivity. Industries that had been limited by manual labor and natural power sources could now expand and innovate in ways that were previously unimaginable. It led to the creation of new industries and transformed existing ones. The textile industry, for example, saw a massive increase in production thanks to steam-powered machinery. The steam engine's influence extended far beyond the factory floor. It changed the way people lived, worked, and even thought about the world around them. It revolutionized transportation, connecting distant cities and shrinking the world. Steam-powered trains and ships made it possible to travel and transport goods over long distances quickly and efficiently. It facilitated the growth of empires and fueled the rise of new economic powers. Countries that embraced steam technology saw rapid economic growth and increased their influence on the global stage. The steam engine, in essence, became the engine of progress. It was a symbol of human achievement and the relentless drive to push the boundaries of what was possible. Its story is a testament to human ingenuity and our relentless pursuit of progress. The inventors and engineers who developed the steam engine were visionaries who saw the potential for a better world. It is a story of inventors and engineers who dared to dream of a world transformed by steam. Their work laid the foundation for the modern world, and their legacy continues to inspire us today. Even today, the steam engine remains a powerful symbol of innovation and progress. While modern technology has moved beyond steam, the principles and spirit of the steam engine continue to drive us forward. In classrooms around the world, students learn about the steam engine and its impact on history. It serves as a reminder of what we can achieve when we harness the power of nature and our own creativity. The steam engine has also found a place in popular culture, appearing in movies, books, and art. It captures the imagination and reminds us of a time when the world was on the brink of a new era. Historical reenactments and museums keep the legacy of the steam engine alive, allowing us to experience the wonder and excitement of this revolutionary invention. The steam engine is more than just a piece of machinery. It is a symbol of human progress and the power of innovation. Its impact on history is profound, and its legacy will continue to inspire future generations. As we look to the future, the principles of the steam engine continue to influence new technologies and innovations. The spirit of the steam engine lives on in every new invention that seeks to push the boundaries of what is possible. The steam engine's role in shaping the world cannot be overstated. It is a testament to what we can achieve when we combine creativity, determination, and the power of nature. Its enduring legacy is a reminder of the incredible potential of human ingenuity. As we continue to innovate and push the boundaries of technology, the steam engine will always be remembered as the invention that started it all. Its impact on history is undeniable, and its legacy will continue to inspire us for generations to come. The concept of harnessing the power of steam dates back to ancient times. Long before the Industrial Revolution, inventors experimented with steam's potential. One such inventor was Hero of Alexandria, a Greek mathematician and engineer who lived in the 1st century AD. Hero's invention, known as the Aeolipile, demonstrated the principle of steam propulsion. It consisted of a hollow sphere mounted on a pivot. Two curved nozzles on opposite sides of the sphere released jets of steam. The force of the escaping steam caused the sphere to rotate. While the eolipile was a remarkable invention for its time, it was not powerful enough for practical applications. It remained a scientific curiosity for centuries. However, Hero's work demonstrated the potential of steam power and laid the groundwork for future inventors. It would be centuries before a practical steam engine was developed, but the seeds of this revolutionary technology were sown in the ancient world. The quest to harness the power of steam had begun. In the late 17th century, England faced a growing energy crisis. The country was undergoing significant changes with the Industrial Revolution on the horizon. This period saw a dramatic increase in the demand for energy, particularly coal, which was the primary source of fuel for heating homes, powering industries, and driving machinery. The demand for coal, the primary source of fuel, was increasing rapidly. As the population grew and industries expanded, the need for a reliable and abundant energy source became more pressing. Coal mining operations were pushed to their limits, with miners working tirelessly to extract this valuable resource from the earth. Mines were getting deeper, and flooding became a major problem. As miners dug further into the ground, they encountered underground water sources that threatened to flood the mines, making it difficult and dangerous to continue extraction. The deeper the mines went, the more challenging it became to keep them dry. Traditional methods of removing water, such as horse-drawn pumps, were becoming inadequate. These methods, which had been used for centuries, were no longer sufficient to handle the increasing volumes of water that needed to be removed from the deeper mines. The limitations of these traditional techniques were becoming painfully clear. Enter Thomas Savery, an English inventor who in 1698 patented a steam-powered pump he called the miner's friend. Savery was a visionary who recognized the potential of steam power to revolutionize the way water was removed from mines. His invention was a bold attempt to address the pressing issue of mine flooding. Savery's engine, while rudimentary, represented a significant step forward in the development of steam technology. It was one of the earliest examples of using steam power for practical purposes, and it laid the groundwork for future innovations in steam engineering. It used steam pressure to create a vacuum, which sucked water up from the mines. The basic principle behind Savery's engine was to use the power of steam to generate a vacuum that could lift water from the depths of the mines to the surface. The engine worked by heating water in a boiler to produce steam. This steam was then directed into a vessel, where it would perform the crucial task of creating the vacuum needed to lift the water. The steam was then injected into a vessel connected to a pipe leading down into the mine. This pipe served as the conduit through which the water would be drawn up from the mine shaft. Cold water was poured over the vessel, condensing the steam inside and creating a vacuum. This process of condensation was essential for generating the vacuum that would lift the water. This vacuum drew water up the pipe from the mine. The water would then be expelled from the vessel, effectively removing it from the mine and allowing mining operations to continue. However, Savery's engine had limitations. While it was a groundbreaking invention, it was not without its flaws. The engine's design and operation presented several challenges that limited its effectiveness. It was inefficient and prone to explosions due to the high steam pressure. The high-pressure steam required for the engine to operate posed significant risks, including the potential for dangerous explosions that could cause serious injury or damage. It also had a limited lifting capacity, making it unsuitable for deep mines. The engine's ability to lift water was constrained by its design, which meant it could not effectively handle the deeper mines that were becoming more common. Despite its shortcomings, the miner's friend demonstrated the potential of using steam power for practical applications. Savery's invention was a crucial first step in the journey towards more advanced steam engines that would eventually transform industries and pave the way for the Industrial Revolution. It highlighted the promise of steam technology and inspired future inventors to build upon his pioneering work. In 1712, Thomas Newcomen, an English blacksmith, patented an improved steam engine that addressed some of the limitations of Savery's design. Savery's engine, while innovative, had significant drawbacks, including the risk of boiler explosions and inefficiency in lifting water from deep mines. Newcomen's engine, known as the atmospheric engine, was a major breakthrough in steam technology. It represented a significant leap forward in the use of steam power, which would eventually fuel the Industrial Revolution. It was the first practical and commercially successful steam engine. This success was due to its ability to operate continuously and reliably, making it a valuable tool for industries that required consistent power. Unlike Savory's engine, which used steam pressure directly to lift water, Newcomen's design was more sophisticated and safer. Newcomen's engine used steam to create a vacuum. This vacuum was the key to its operation, as it allowed atmospheric pressure to do the heavy lifting. This vacuum then allowed atmospheric pressure to push a piston down, a process that was both innovative and efficient for its time, which in turn operated a pump to raise water. This mechanism was particularly useful in coal mines, where water needed to be removed to access the coal seams. The engine worked by injecting steam into a cylinder, located below the piston. This steam was generated by boiling water in a separate boiler. The steam pushed the piston upwards. This upward movement was crucial as it set the stage for the next phase of the engine's operation. Cold water was then sprayed into the cylinder, condensing the steam and creating a vacuum. This condensation process was rapid and efficient, ensuring that the engine could operate continuously. Atmospheric pressure, acting on the top of the piston, forced it down. This downward stroke was the power stroke of the engine, driving the pump mechanism. This downward stroke operated a beam connected to a water pump. The beam acted as a lever, amplifying the force generated by the piston. Newcomen's engine was more efficient and safer than Savory's design. Its ability to operate at lower pressures reduced the risk of explosions, making it a more reliable choice for industrial applications. It quickly found widespread use in coal mines throughout England, revolutionizing the mining industry. The ability to efficiently pump water out of mines allowed for deeper mining operations, increasing the availability of coal. The engine's success paved the way for further advancements in steam technology. It inspired future inventors and engineers to refine and improve steam engines, leading to the development of more powerful and efficient machines that would drive the Industrial Revolution forward. Innovators like James Watt and Matthew Boulton built upon Newcomen's work, creating engines that were even more efficient and versatile. These advancements had a profound impact on transportation, manufacturing, and many other industries. Today, the principles of steam power are still in use, with modern steam turbines generating electricity in power plants around the world. The legacy of Newcomen's atmospheric engine lives on in the technology that powers our modern world.